Magudeeswaran, Professor in Mechanical Engineering, PSNA College of Engineering Technology, Technical. Today I am going to deliver a lecture on the arc welding. Introduction. Welding is a process in which two or more parts are coalesced at their contacting surfaces by the application of heat, pressure, or both heat and pressure. Some welding processes uses a filler material that is added to facilitate coalescence. Coalescence means that some parts are melted and they are liquefied and then they are solidified, and thus the joint is established. And why welding is so important in manufacturing process is that it provides a permanent joint. Welded components are being a single entity, and one of the most economical ways to join parts in terms of material usages and fabrications. And mechanical casting usually requires additional hardware, example screws and geometrical alterations of assembled parts. And it is not restricted only to a factory environment. Welding can be carried out, accomplished and in the field also. Thus, the welding plays an important role in any manufacturing process, and without welding, no structures can be facilitated for applications in engineering. Limitations and drawbacks of welding. Most welding operations are performed manually and are expensive in terms of labor cost. This is true because unlike other manufacturing processes, welding involves a lot of skill. Most of the welding processes uses high energy and are inherently dangerous. And welded joints do not follow convenient assembly and disassembly because it's a permanent joint, and welded joints can have quality defects that are difficult to detect. Also, these are the very important drawbacks of welding. But however, these drawbacks, in spite of these drawbacks, welding is carried out for structural applications in engineering. There are two categories of welding processes. Namely, one is the fusion welding, coalescence, that is welding followed by solidifications, and then the two parts are joined. In some cases, the filler material is added to the joints. Examples are welding, oxy-fuel gas welding, and resistance part welding. Solid state welding process. Here, heat or pressure are used to achieve coalescence, but here there is no melting. Melting of the base metal occurs and no filler material is added. Examples: forge welding, diffusion welding, and friction welding. Now let us concentrate only on the arc welding part of this in this webinar. Now, this fusion welding or the arc welding, in which the coalescence of the metals is achieved by heat from an electrical arc between the electrode and the buck. The electrical energy from the arc produces a temperature ranging to 10,000 Fahrenheit and to a minimum of 5,500 degrees centigrade, hot enough to melt any material. Most of the arc welding process add filler metal to increase the volume and strength of the joint. Thus, it involves the electrical energy combined to heat the material, and then the material melts and then it solidifies to give a permanent joint. The types of arc welding process includes, these are the most important welding processes that are used in the industries. That is shielded metal arc welding, popularly known as SMAW, gas metal arc welding, popularly known as GMAW, flex core arc welding process, popularly known as FCAW, and submerged arc welding process, popularly known as SAW, and then the gas tungsten arc welding process, which is popularly known as GTAW. These processes are associated with molten material, and then they perform under the action of electrical arc combined with melting and solidification of base metal and the filler metal design. Now, first, we'll look into the shielded metal arc welding process first. See, this is the basic principle of this shielded metal arc welding. Here, we have a work, and we have an electrical power source in which it is connected to the electrical plug, and then it is completely earth, and we have a torch in which the electrode, that is this, it is a it's a stick electrode, and then one part of the base metal is connected to the other version of this electrical connect, and then the electrical circuit is established. And this is commonly known as stick welding or manual arc welding. This is the most widely used arc welding process in the world, and can be used to weld most of the common metals and alloys. See, this is one of the versatile welding process which are day-to-day 90% of the total welding fabrication depends only on this particular shielded metal arc welding process. Now, this is the schematic sketch of the SMAW of the shielded metal arc welding process. This is also called as manual metal arc welding process because it is done manually. See, here is the base metal, this is the cross section, this is the base metal, and this is the electrode. This is the typical stick electrode. This electrode will be connected to the one end of the electrical cable, and the base metal will also be connected to the other end of the cable. Once the arc is struck in between the base metal and the electrode starts melting, and then the fusion is carried out. And then the welder has to travel along the weld direction as per his basis and directions. See, the biggest beauty in this particular welding process is that, see, this electrode is a special type of electrode where the inner part is going to be the core, or we call this is the core metal, and this metal is nothing but the welding rod, and above this a layer of flex, a layer of chemicals consisting of silicates, oxides, etc., will be embedded in this, and then this is called as flex, and this flex acts as an agent. When the electrical energy is passed into this conducting electrode, first this flex melts, and then it produces a shielding over the entire region of the air in order to avoid the atmospheric contaminations. That's why it is called as shielded metal arc welding, because the shielding gas is produced by the chemical reactions or the melting of the flex. Remember, this flex are low melting agents. This melts faster than the core wire, which is inside the flex. Now this is the cross section of this electrode, and here you will be able to see that inside you have a metallic rod, and then the top surface you have the flex. You will have the flex, and it is a consumable. It gets melted during the welding process. It composed of this electrode composed of two parts. One is the core rod, the metal filler carries welding current and becomes the part of the weld. And flex coating, it produces shielding gas and can provide additional filler, and it forms what it calls as a slag. Slag is nothing but it's a chemical compound that is obtained out of the gas metal reactions. This is the welding arc. See, this arc occurs when the electrode comes in contact with the workpiece and completes the circuit. It is like something like a turning on the light. The electric arc is established in the space between the end of the electrode and the work. The arc reaches the temperature of about 10,000 degrees Fahrenheit, which melts the electrode and the base metal together. The faces of the base metal, here you will be able to see that the welding is carried out in a vertical position, and this is the stick electrode, and the welder is able to operate on any position on these vertical positions. Now, there are two types of way by which you can strike a arc. One is the scratch arc. See, it is just initiated. The tip of the electrode is just touches the workpiece, and then it is just lifted up. And this is called as what you call as a scratch off method. And you have got a taper method. You have to bring the electrode in contact with the workpiece, and then you have to lift up the arc is struck. Both this process or both this base of this striking with the arc
can be used depending upon the welder's interest and welder's compatibility. And this is the weld puddle. See, as the core rod, the flex coating and the workpieces heater melt, they form a pool of molten metal. And this molten metal is called as the weld puddle. The weld puddle is what a welder watches and manipulates this welding. He cannot look up the solidified matter. Only the welder will be able to see what is this weld puddle. Depending upon the characteristic feature of this weld puddle, this welder will be able to adjust his hand rotation, etc. during the welding. Now the shielding gas. Let us now discuss about how the shielding gas is produced in the shielded metal arc welding. The shielding gas is formed when the flex coating melts. This protects the weld puddle from the atmosphere, preventing contamination during the molten state. This is the burning. That's why it is called as shielding gas. Now you can connect this electrode and the workpiece either to the positive terminal of the electrical circuit or negative terminal of the electrical circuit. If you connect the positive terminal to the base metal, then it is called as straight polarity. And if you connect the negative terminal of this electrical circuit to the base metal, then it is called as reverse polarity. Both the polarities can be used when you want to have a shallow penetration. And for thin materials, you can go in for this straight polarity. And then for reverse polarity, we will be having a deeper weld penetration, and it is used for welding thick sections. And here in this shielded metal arc welding process, only DC current is used and no alternating current can be used for welding purpose. Now this is the pictorial view of the solidified metal. As the molten metal puddle solidifies, it forms a joint or the connections between the two pieces of the material. And when done completely on steel, it results in a weld stronger than the surrounding base metal. Sometimes the welds are more stronger than the base metal, and we will have a permanent type of joint. Now the slag. See, slag is a combination of flex and the impurities from the base metal that float to the surface of the belt when the base metal and the electrodes are melted. Now the slag quickly solidifies to form a solid coating. See, the flex ingredients of the flex are low melting components. They solidify. They melt so quickly, and then they solidify so quickly than the core wire, and they form what is called as a solid coating. See, the slag also slows. The slag also slows the cooling rate of the weld, and the slag can be chipped away and cleaned with a brush when hot. See, this slag is an important feature in the shielded metal arc welding. See, it is the end product of the flex melting. See, the flex are nothing but oxides, fluorides, carbides, etc. They are combined together, and then they are coated on the top surface of the electrode. When the electrical arc is stuck between the electrode and the base plate, what happens is that the flex starts melting, and then the core wire, and then in the molten weld pool, this molten flex starts reacting with the impurities, and they form a low density compounds, and they start floating in the upper surface of the weld. And once they solidify, they form a layer, and that layer is actually that has to be taken away, or that has to be chipped, or that has to be ground in order to get the pure weld. But there is one advantage with this particular slag, because it facilitates for the cooling rate of the weld, which is very important as far as the liquid to solid transformations in the shielded metal arc welding process. See, and then this is the photographic view. Here the welder welder has performed welding in the railway track, and he chips the slag inclusions, which is available in the top surface of the weld. Now let us go back to the disadvantages of the welding. Low initial cost, of course. The machines are very portable, and it is easy to use in outdoors, and it can be performed in all positions. You can go horizontal welding, you can go vertical welding, you can go downhand welding, uphand welding, any positions, and it is easy to change between many base metals, and this is one of the versatile process. That's why this welding industry, in the welding industry, 90% of the total welding is carried out only by this shielded metal arc welding process. There are limitations. It is lower consumable efficiency, because every time you have to change, you cannot get a continuous weld, and difficult to weld very thin materials. It is not suitable also. It is not suitable to weld thin materials, and frequent restarts because the normal size of the length of the welding rod maybe 30 centimeters or 40 centimeters, and after that the welder has to change the rod, and that is one of the biggest problem in this shielded metal arc welding. And lower operating factor, because the machine is also not capable of executing very high temperature, so it is not also suitable for very high temperature material welding. And then higher operator skill is required for SMAW, and then some other processes. This is very, very important, because this process only depends upon the welder to get good quality of welding, because the welder has to be trained in proper manner, otherwise this shielded metal arc welding process cannot be performed. So there are quality issues. See, as I told you earlier, that the flux melts, and then it reacts with the base metal impurities, and it forms a slag. Sometimes these impurities get along inside this weld pool, and they form what you call this is slag inclusions, and these inclusions serves as a crack. And after the weld is solidified, and you will be able to see the cracks once if these impurities are embedded inside the solidified weld metal. And the discontinuities are associated with manual welding process that utilizes flux for shielding, and they have the two common defects that are caused by this flux are nothing but this slag inclusions and sometimes lack of fusions. Other possible effects on quality are something like that of porosity, that is the holes will be formed, and then the hydrogen cracking, because the flux is usually made up of silicates, and some parts of calcium is also there, and then it will absorb moisture, and this hydrogen gets entrapped into it, and then it bursts, and then the discontinuities and crackings are found. So in order to avoid all these things, what you have to do is we have to bake or the heat the electrodes in a oven, as such that the moisture on the top surfaces of the flux are completely removed. Then only you have to use this particular electrode for welding process. Limitations, and then you have got low deposition rates, low productivity, and operator dependent. In spite of this, shielded metal arc welding process is a very good process for repair welding, especially for repair welding, and for certain structural applications. They demand only this manual metal arc welding, because it can be performed with much care, because it is the human being that controls the welding business. See, next, before getting into this gas junction arc welding, let me summarize what is this shielded metal arc welding process, applications of shielded metal arc welding process. See, you have got wide applications of this shielded metal arc welding process, right from boiler manufacturing, thermal power plants, structural applications, railways, and nuclear power plants, etc. you can go in for all these things. All metals can be welded in this sheeted metal arc welding process. But only one care should be taken, that the welder has to perform welding in a particular fashion, such that he or she has to understand the knowledge of this particular welding. Otherwise, it's a very good process. The next process is gas tungsten arc welding process. It is also called as tungsten inert gas welding process. That is GTAW, or this is always called as, popularly called as TIG welding. See, in the case of SMAW, the electrode is a melting component, and it forms a part of the weld. But here, in the case of this TIG welding or GTAW welding, the electrode is a tungsten rod, and it is non-consumable, and it does not melt. It produces only an arc, or it can be called as a heat source. The filler rod is separate and fed manually. Thus, you have two entities. One for generating the arc, and one for filling up. The filler rod is added manually. See, and then you have got shielding gas that protects the weld, and then weld and the tungsten rod. And remember, here only inert gas is used. That's why it is called as metal inert gas tungsten arc welding process, because it uses tungsten electrode, non-consumable tungsten electrode. It is also called as tungsten inert gas welding process, because only inert gases are used in this particular welding process. See, this requires high level of skill to operate this, because in one hand the welder has to have the torch, and on the other hand the welder has to feed this the filler rod. And that's why it is a lot of skill when you compare with that of the sheeted metal arc welding process. The welder in the TIG welding process has to normally have a high skilled labor. Now, next thing is, it is very difficult to automate. It is very difficult to automate, because two things are involved. One is the tungsten rod, and another thing is the filler rod, which are two separate entities. And then we cannot automate this. And remember, it is a low heat input process, and small weld bead produces one small weld bead, and you can have a distortion, that is the buckling of the plates when it is welded, and the grind growths are minimized because of this low heat input process. In spite of all these characteristics, it produces clean welds, because there is no flex involved in this. Tungsten inert gas welding process is the most recommended process, especially for nuclear power pressure vessel, because there you will not have any inclusions. Only this, the filler is added externally, and this filler metal chemical composition is also the same as that of the base metal. So one can say that tungsten inert gas welding process is a clean welding process when compared with the former process, that is the sheeted metal arc welding process. But one thing is it is a very slow. It requires lot of skill during the operations. This is the schematic sketch of this GTAW machine. You can use AC, you have an alternating current or the direct current, and you have got the power supply. You have the welding torch. And the workpiece is fixed to the two poles of the power supply. See, here this is the welding torch. And here this is the tungsten electrode, non-consumable tungsten electrode, which is kept in the center line. And then the shielding gas is also passed into it. And once the arc is stuck in between the workpiece and the non-consumable tungsten rod, the filler material is inserted inside the welding arc, along with the shielding gas. That is the shielding gas. It protects not only the non-consumable electrode, but also the filler metal from any atmospheric contamination. And also the shielding gas which is used is normally the inert gas, so there will not be any reaction between the weld metal or the base metal portion. That's why it is called as a clean welding process. So this is the tip torch parts. You have the electrode cap. This is the tungsten electrode, and you have the nozzle, and this will be connected to the shielding gas hoses, and then this electrode cap will be fixed inside this collet, and then welding will be facilitated. And the welder, it is very handy. That the welder normally keeps this particular electrical torch in the left hand, and then he inserts the filler metal in the right hand. So this is the diagrammatic sketch of schematic sketch of the entire TIG welding process. Here you have the shielding gas. Here, this is your tungsten electrode, and this is your welding arc, and then you have got the gas nozzle and the torch body. Right, and this is the filler material, and this is along the welding direction. You will be able to see the solidified material. And then this gas shielding is very important as far as this TIG welding. As I said earlier, it protects three things. One is the tungsten electrode, the filler material, and the weld pool, and making it less contaminate or no contaminate with the atmospheric entrance. See, to facilitate again, say this in the TIG process, an arc is struck between the non-consumable tungsten electrode and the workpiece. This is the pictorial view of this particular TIG welding torch, and the arc is struck between the electrode and the base material. And this is the filler rod. This is the filler rod. And when the filler rod is used, it should be used in the same composition of the material. The filler rod is fed manually into the leading edge of the welding puddle, and that's why you'll be able to see that this the welder handles the torch in one hand and the filler material in other hand. Usually the torch is held in the left hand, and the filler is held in the right hand for easy operations. Depending upon the welder's skill, filler materials can also be kept in the left hand, and the torch can be kept in the right hand. But one thing is it all depends upon the welder's skill. See, you can use the polarity. You can use this is the as I said in the shielded metal arc welding process. You can have this DC current straight polarity, where the electrode is connected to the negative terminal, workpiece is connected to the positive terminal. Then you can use the reverse polarity too, where the electrode is connected to the negative and the base metal is connected to the positive terminal. Remember, most TIG welding process is done with alternating current or this DC state polarity. When welding is done with AC, the machine will be either balanced or unbalanced depending upon the welding current used, because for half of the cycle it will be DC state polarity, and for half of the cycle it will be DC reverse polarity. With the AC machines, the current in theory flows from DC straight polarity in half of the tank and DC reverse polarity in half of the tank, as I said earlier. And this particular AC TIG welding machines are widely used for welding aluminum alloys rather than any other alloys. But depending upon the materials, depending upon the characteristic feature of the filler material used, sometimes dissimilar combinations of the filler materials also can be used for wanted applications. So in that case, you can choose either DC reverse polarity, straight polarity, or the AC cycle, depending upon the nature. Next thing is the quality metal process weld. See, this produces, you will be able to see a shiny weld without any flaw-free weld. There is no slag inclusion because there is no flux involved. So we will be able to get high quality of welds. In spite of its manually operations, you can get good quality of welds. And remember, that's why it is called a clean process, because it uses inert gas welding. and then the filler material is added externally depending upon your choice, and then we can get the quality of the belts as per our own desired design in the belts. See, there are more advantages. Belts more metals, and you can get variety of materials, and you will get high quality and precision welding. And you can get, once the belt is rubber, you can get a shiny appearance, so you get an aesthetic belt base, and there is no spatter and no slag and no smoke or fumes, because in the case of shielded metal arc welding process, you can have smokes due to the melting of the flux, but here there is no smoke, there is no splatter, because it uses only very low current, and then that's why it has got its own merit. And remember, the entire nuclear pressure vessel or nuclear industries for certain critical applications, they recommend only this TIG welding process, or the tungsten inert gas welding process, or the gas tungsten arc welding process. In spite of its advantages, we have got certain disadvantages, which includes low filler metal deposits, because it is manually operated. The operator has to operate in both hands, so it will be a very slow process, and good hand-eye coordination is required, and it's a skill. Remember, both the hands and the eye coordination is required to make the weld by using this tungsten inert gas with tungsten electrode, because if the coordination between your hands and eyes are lost, then you will not be able to achieve good welding. And remember, see, the arc is produced. When the arc is produced, there are some ultraviolet rays are also produced when compared with the other process, and it is not usually high protective glasses like as shown in this figure are worn by this welder. See, and then remember, this process, this TIG welding process of the gas tungsten inert gas welding process, it's very slow. The travel speed is very slow when compared with the other process. And remember, the equipment cost tends to be higher than the other process, because it has to accommodate so many other features like the AC current, DC current, and other features, and hence these are disadvantages of this particular process. But in spite of this, the TIG welding is widely commonly used welding process in the most fabrication industry, next to the shielded metal arc welding process. Now, before getting into this gas metal arc welding process, let me express some views on the difference between the shielded metal arc welding process and the tungsten inert gas welding process. See, tungsten inert gas welding process uses a non-consumable electrode, whereas the SMAW uses a consumable electrode. Here inert gases are used, and here no inert gases are used in the case of SMAW process. And there is no slag, because flux is completely absent in the case of TIG welding process. In the case of shielded metal arc welding process, you will be having what you call the slag inclusions, and the shielding is facilitated by these things. In spite of these two processes, that is the shielded metal arc welding process and the TIG welding process, they are manually operated. The next gas metal arc welding process. This is otherwise called as metal inert gas welding process. So the principle of the welding process, that this GMAW process is something like this. So the GMAW stands for gas metal arc welding process. A solid metal wire is fed through the welding gun and becomes the filler material. Shielding is used to protect the molten puddle from the atmosphere and results in the weld without any slag. And GMAW is the most recommended welding process and widely used welding process, especially in the countries like USA. This is the process setup. You have the power supply, and you have the shielding gas, and you have the welding torch, and here you will be having the electrode or the welding wire, and this is fed inside this torch, and as usual the arc is established between the electrode and the base material, and thus the welding can be done. But here there is a difference between the shielded metal arc welding process and the tungsten inert gas welding process and this GMW welding process is that, see here the wire, the fillet material is fed continuously, and this process is a semi-automatic process. The welder will have the control only, will be controlling the torch movement, and if required he will be able to control the feed rate in which the filler wire is fed inside the arc. See, this is the principle. This is the schematic sketch of this GMW process. This is the power source which will be connected to the electrical circuit. Here you will be having the shielding gas circuit, and this is the wire spool. The electrode in the form of wire, metallic wire is placed here, and here there are wheels that is called as wire feeder, and this electrode wire is fed inside this torch, and also the gas is along fed inside along the other side, and the workpiece is connected to the other terminal of the electrical circuit, and once the arc is established and the wire feeder is on, the wire is fed automatically, and then the welding can be continuously executed. Remember, the wire does not have any flex coating. It is called as a bare wire electrode. Like that of the tungsten. In the case of tungsten inert gas welding process, you have a bare wire which is fed externally inside the arc column. Here, a spool of wire is fed continuously inside the torch, and in the pool of shielding gas, and the arc is executed in as usual in the same mechanism as that of the shielded metal arc welding process. Remember, these are the various components of this GMW process. Generally, a drag it is used for both thinner materials and thicker materials also, and you will be able to see that here you have the shielding gas, and this is the wire, and you will be having a coolant such that the torch should not be heated too much. So we will be having a coolant because it is a continuous process. The wire is fed continuously, and then the shielding gas is also fed continuously. The arc is not extinguished till the operator or the welder wants to do it. Since sometimes it may be called as a continuous process, and it is well suited for mass production, or sometimes it can be automated too. Though it is a semi-automatic process, it can be automated to get a similar quality of welds or a for long stream of welds. Especially in the boiler manufacturing, nowadays they start using this particular GMW wires instead of this SMW or this TIG wire. See, this is just an extension of the TIG wire, welding process. Because in the case of TIG process, the wire is fed manually and it's a slow process. But in the case of GMW process, the wire is fed through a wire feeder, and it is controlled by the operator itself, and then the entire system comes into the torch, and then the welder will be able to perform this entire operation with a single hand. So when you compare with this TIG welding process, here the skill is not that much required, but the controlling of the torch is very essential, and the welder has to have the skill on this particular aspect in the case case of this GMAW process. And here you will be able to see that the shielding gas products three things. One is the torch and the electrode and the molten puddle. And remember, you will be able to get the exact quality of the belts as in the case of TIG welding process, because there is no flex, no slag inclusions, and since the inert gas is only used, and there is no gas metal reactions and unwanted inclusions or compounds will be formed in the solidified metal or the belt. See, this is the schematic sketch of the spools of the GMAW electrode, and it's a metal wire, and it is measured by its diameter. And then the GMAW electrodes are commonly packaged on spools wheels ranging from 1 lb to 1000 lb of length. And this is something like an electrical wire cable. But only thing is, in the electrical wire you will be having an insulating layer. Here there will not be any insulating layer. One is a metallic wire, and remember it is a conducting wire. One has to be very, very careful when you insert this particular metallic wire in the torch of the MIG welding equipment, because the diameter of this wire is very, very thin. Sometimes it may tend to break. So we have to be careful while inserting this particular wire spool into the wire feeder and the torch. Next thing is the GMAW welding arc. An electric arc occurs in the gas-filled space between the electrode wire and the workpiece as earlier. Remember, it can generate up to 10,000 degree Fahrenheit, and sometimes higher deposition rates also facilitated in the case of gas metal welding process. Remember, as the wire, this particular figure shows this GMAW belt puddle or the molten metal, as the wire electrode and the workpiece heat up, melt, and form a full of molten material. And this is called as a belt puddle, as I said earlier. And this is what the welder has to watch very, very carefully, because it is the belt puddle. It is the belt puddle, the nature of nature, and the manner in which the belt puddle is generated by his hand movements. That facilitates the quality and the strength of the belt sometimes. So the welder has to have an eye on the belt puddle instead of the other components in the belt, because there is no other components he has to watch, because here the wire is fed automatically. Only thing is he can control the speed of the wire initially, and then he can keep on welding this. But only one problem is that the welder hand technique is very, very important in this particular MIG welding process. This again a shielding gas. Sometimes this inert gas is mixed with other combinations of inert gas, and then you can get variety of nomenclatures, variety of quality of belts in the case when you use different welding gases. See, this shielding gas can affect the following things. One is the weld being sheet. Yes, it can affect arc heat, stability and starting, and it can affect the surface tension of the liquid, drop size, puddle flow, and the spatter. Remember, these pictorial flux cord wires are in place in industry. The welder will find very, very, very difficult, because he has to inhale the air, contaminated air, though he will be having a protective clothing. He has to inhale the gas that is coming due to the flux, and also due to this particular shielding gas. And this is one of the reasons, more smoke and fumes. That's why the welder does not prefer this welding process. But it has got a lot of applications. Spatter is also a problem, because sometimes the too low current is used, the flux starts melting and the wire does not melt. That is also one of the things. And FC wire is more expensive when you compare with it's more expensive when you compare with this GMW process, GMW wire, and the equipment is more expensive and it is more complex than that of for the conventionally used SMAW process. So far we have seen 4 important types of process, namely the shielded metal arc welding process, the tungsten inert gas welding process, the metal inert gas welding process, and the flux core arc welding process. All this process can be performed for a good welding, provided if the operator or the welder is skillful enough to perform the activities. But in an industrial scenario, you cannot depend mostly on the welder, because the welding becomes costlier when the skilled welder is required, because we have to give salary to him, and then we have to give proper training to him. For different jobs, different skills is required. So all these things has a hidden cost. So that's why this welding is always costlier. So in order to avoid that, there is, and also this process, that is shielded metal arc welding process, this metal inert gas welding process, and the GMAW process, and the flux core arc welding process, they cannot be welded for a thicker plate in one pass. Only multiple passes, one pass, the second pass, and third pass, like this, you have to weld and then deposit. For example, if you have a 12 mm thickness plate, as far as this GMAW, as far as this SMAW process, you have to bend at least 2 times or 3 times in order to fill the gap. In the case of TIG welding process, you require more, and in the case of MIG, it may be 1 or 2. But a 12 mm thickness plate, by using arc welding process to make it to get it welded in one single pass, it's very difficult manually. It is not possible. Only with respect to automatic process, it can be. One such process is submerged arc welding process. The name, there are 3 words. There are 2 words. One is submerged, then you have got arc. The arc is submerged. The arc is not visible. The arc is not visible to the welder. As in the case of shielded metal arc welding, or the TIG welding process, or the GMAW welding process, or the flux core arc welding process, the arc can be controlled by the eye contact of the welder. But here the arc will be submerged. Only thing is the welder or the setter has to first set it, and then the arc is invisible. That's why it is called as submerged arc welding process, and it is a fully automatic process. The principle and operations of this are as follows. Welding arc is shielded by a granular flux consisting of silica, lime, manganese oxide, calcium fluoride, and other components. Flux is fed in the weld zone by gravity flow through a nozzle. The thick layer of flux covers the molten metal. Flux acts as a thermal insulator, promoting deeper penetration of heat into the workpiece. And consumable electrode is a coil of bare round wire fed automatically through a tube. Remember, here what we are doing is we are taking advantage of all the processes. Here, the basic requirement of the submerged arc welding process is that you need a bare wire in the form of a coil like that of the MIG welding process, and the flux has to be supplied in the powder form. These are the 2 important requirements as far as this submerged arc welding process is concerned. See here, you have the flux hopper. This is the hopper or the nozzle-like arrangements in which the flux in the form of powders will be fed, and there will be an opening. And this flux is this entire system, and there will be an electrode or the wire. These 2 things will be joined together, and then it will be in the form of a carriage. And remember, this particular hopper in which flux is fed will be in front side of the will be in front to the electrode wire or electrode feeder or the bias feeder and you can use both alternating current as well as direct current also. And remember, this arc will be initiated between the base metal and the electrode, and remember this flux covers this particular arc, the tip of the electrode, the fairing surfaces and the molten weld pool on the arc. All these things are submerged inside. See, here the consumable wire is an electrode, shielding is provided by granular flux, and you will have, see, the low UV radiations and fumes that has been experienced in the case of big welding is completely nullified, and flux acts as a thermal insulator. Remember, in the case of flux core arc welding and in the case of shielded metal arc welding process, the flux acts as not as an insulator but as a shielding agent. It produces fumes and it melts and it produces gas, and the gas shields the atmosphere of the weld pool. But here it acts as a thermal insulator. Thus, it not only provides shielding shielding from the atmospheric contamination, but also it facilitates for uniform cooling after the welding is also. It is an automated process, but only one disadvantage is that it is limited to only horizontal welding. You cannot weld it vertically, and only flat plates and sheets can be welded, and it is high speed. It is 4 times to 10 times that of the shielded metal arc welding process, and the current range is 440 volts. Remember, high energy process. This is otherwise called as high energy process, and it is not suitable for welding thick plates. When you want to go in for it is not suitable for thin plates, it is suitable only for thick plates. When you want to go for thick plates, you have to compulsorily use this shielded metal arc, this Shamaj arc welding process, because it produces high energy. Large amount of metal, filler materials can be melted in a short time, and there is only a partial melting of the flux, so there is no fumes also, and also the deposition rate is very high because of this high current, and these are some of the advantages. Remember, the boiler pressure vessel casings are welded, that is 20 mm, 30 mm plates are welded only by using automated submerged arc welding process. And this is widely used. This is the most widely process that are used for fabrication of thick walled boiler pressure vessels. That I am talking about the walls of the boiler pressure vessels are being welded. For example, the cylinders are made by just bending the sheets. So when you want to weld the gap between the two sheets that are bent, you have to use only this thing, and then only horizontal welding is facilitated for this by this submerged arc welding process. And remember, there is one disadvantage: it is cannot be used for thin plate welding. Minimum thickness is 12 mm, and remember, multi-pass welding is not possible here because everything is shielded or submerged inside this thing. But one thing is, you can use 2 wires or 3 wires depending upon your requirements. When you want to weld a thick plate, when the groove size is 1 meter, or half a meter, or a few millimeters, when you want to deposit more wire, you can feed 2 wire or 3 wire depending upon your rate. You can use this particular directions. And this is the pictorial view, and this is your electrode feeder, and this is your hopper, and where the flux is. This is the granulated flux. And remember, the flux can also be reused to a certain extent. And this is the typical view of this particular thing. This is the workpiece, and this is the wire, and this is the flex, and this is the weld metal. Sometimes due to excessive current, sometimes a partial melting of this flex is also can happen, and that will result in small slag intrusion that can be machined off. There are advantages: higher deposition rates. Yes, because of high current, you can get higher deposition rates. There is no arc or flash. See, in this particular thing, the welder is free to operate only the current settings, and he is not in a position to watch the arc. Minimal smoke and fumes and smokes are not there, because the flex acts as a thermal insulator, and it protects three things. One is the tip of the electrode, molten melt pool, and the fairing surface of the base metal from the atmospheric contaminations, and everything is submerged inside the flex. And then the flex actually do not burn, but one thing is sometimes a partial melting will be available. Flex and wire added are separately, and you can get this is an extra dimensional control. You can have a faster wire speed, and this is not dependent. This flex feed and wire feed are not dependent on each other. They can be controlled independently, and it can be easily automated. Joint can be prepared with narrow grooves with a minimum included angle. You can prepare the joints, or it can be welded, and can be used to weld the carbon steels, gold alloy steels, stainless steels, chrome alloy steels, and nickel based alloys. High welding, it is more suitable process for high welding alloys. So these are the main advantages of this particular shielded membrane, submerged arc welding process. But yet it has got certain limitations. Flex obstructs the view of joint during welding. This is a very important aspect or the drawback with respect to this submerged arc welding process is considered, because the welder does not have any control over the welding arc, because everything is submerged. Sometimes even when you want to control the arc, the welder is not in a position to control it. Cannot do things. See here, you can eliminate the word as welder. He is just an operator who is operating that particular welding machine, because he doesn't carry anything in hand. Welder or the operator does not take any torch in the hand. Only thing is a carriage is there. The carriage is capable of moving. Everything can be automated, and this is one obstacle. There is an advantage, and the obstacle is that the welder cannot view this welding arc. Next thing is flex is subject flex when it is exposed to atmosphere, because flex is spread only on the base plate surface. So when it is there, it will absorb moisture and it is subject to contamination. Only the careful reuse is you have to use this reclined reflex. It is called as reclined reflex. Reclined reflex is that not all flexes can be used. Only the topmost surfaces, flex in the topmost layer can be used for this particular thing, can be reused for this submerged arc welding process again, and it results when you use this contaminated flex, it results in the porosity. Normally, I told you it is not used. It is used for thin materials. When you use thin materials, more melting will happen, and then the cracks may deteriorate the quality of the belts. And it is restricted to flat positions for grooves and flat and horizontal for fillet. It is only horizontal welding can be, or the X direction only it can be welded, and slag removal is required. Remember, the slag produced in flex core arc welding and shielded metal arc welding are quite different from that of the slag that is produced in the submerged arc welding process. Because this particular slag will be like a paste, and it will be embodied on the top surface of the molten welded coal. After it gets solidified, and it will be something like a paste. It cannot be easily peeled out. Only the grinding wheels have to be used, and a separate flux handling equipment is necessary for drying and handling and storage. Storage places have to be available in the site. So, in general, this submerged arc welding process is a fully automatic process. It can be used for welding the thicker plates, and main applications being the boiler pressure vessel manufacturers, and single pass welding can be facilitated depending upon the thickness. And in the case of other welding process which we have seen, only a single electrode or single wire can be used. But in the case of submerged arc welding process, you can use 2 wire or 3 wire, either one after the other, or in tandem also it can be used. Thus, this particular submerged arc welding process nullifies all other the difficulties faced by all other processes. But only one disadvantage with this particular process is that it is not used. It cannot be used for thin welding process. So far we have seen 5 important processes. Let me summarize those things. Shielded metal arc welding process is a welder dependent process. It is fully manually operated. It uses a consumable electrode in which a metallic rod is coated with a flux. The shielding is effectively done by the melting of the flux. The next comes the TIG welding process or tungsten inert gas welding process, and it is also a manually operated process. Here in this process, it uses a non-consumable tungsten electrode which will generate only the arc. The filler rod is fed manually or externally, and then the welding is facilitated. And this has one advantage, is that it's a clean welding process. Next comes into this is the MIG welding process. That is the metal inert gas welding process. That has an advantage of performing high deposition rates because it's a semi-automatic welding process, and you can have good quality of welds for high deposition rates, and welding can be facilitated much quickly. It is a modification, or it's an automated. It can be called as an automated TIG welding process also, because it uses it is another version of TIG welding process. And then flex core arc welding process, it combines both aspects of shielded metal arc welding process and the manual metal arc welding process, and it can be facilitated. And you got the advantages of using self-shielded and gas shielding process also, and that is the welding process. Nowadays, the flex core arc welding process finds its uses, and sometimes it replaces MIG welding process also nowadays. And then the last, this submerged arc welding process, it's an automatic process. The welder does not have any control over the arc. It can be used for, it's a high energy process, and it can be used only for thicker plates. And remember, the shielded and the submerged arc welding process cannot be used for repair welding at any costs. So I think this lecture will give you a broader idea of the 5 important arc welding processes, that are used in industries for fabrications. There are very many other welding processes that are used for different applications, but yet, as far as the industry scenario is considered, these 5 important processes, that is SMAW, JMAW, ZTAW, FCAW, and this SAW process finds its own place in the thing. There are a lot of welding processes, but you cannot neglect the fusion welding process. It is the fusion welding process that will enhance the welding quality. Thank you very much.